diameter 6 meters, the pile with diameter 4 meters. So we'll be able to apply to get these two lines. And we already know the maximum moment, maximum horizontal load for each system from our statical load. So we'll apply these points, and we can see it's near the main line. But we don't have an equation for the hybrid foundation system. So we applied our maximum moment, maximum horizontal load for the hybrid system with different blade diameter. And from this line, we'll be able to get this new equation by adding the effect of the blade depending on the blade diameter. So we can see here it's for different blade diameter. We can see here starting from diameter 16 ending with diameter 22. After applying this equation, we redraw the figure here, and we can see there is good agreement between our results here of the equation and the field test. After doing static load, we have done cyclic loading test. We can see also this cross section of the system. For cyclic load, we already have done this by using a hydraulic actuator from mechatronic department. By depending on the air pressure and the size of the actuator, we'll be able to know the required load to move the pipe. So for cyclic loading, we needed to study the long-term cyclic loading effect. So as we can see here, this is the actuator here, and this is the air pressure. By knowing the air pressure and the area of the piston, I'll be able to know the required load here. We already studied the effect of several number of cycles, up to 12,000 cycles, on the stiffness of different foundation system as 4 meter diameter, 6 meter diameter, and hybrid system. And we can see here with different number of cycles, we can see that the change in stiffness in the hybrid foundation system is, we can say, constant or making steady. So this is the effect of the plate. The same thing as the change in rotation of the different system for monopile 4 meter diameter, monopile 6 meter diameter, and our hybrid foundation system. And as we can see, till I think 6,000 cycles, it will be as constant K. So our conclusions: we will be able to provide actual 6 components of load at the base of 5 megawatt NREL wind turbine to be used by any researcher in the future design for the foundation. We provide our hybrid foundation system, which will be smaller, monopile diameter 4 meter compared to the monopile with diameter 6 meter. We have seen that we cannot just depend on 2 components in our analysis. We need to have 3 or 6 components. We have seen the increase in hybrid capacity under the vertical capacity of the hybrid system. We can see also that although the difference between the lateral capacity of the monopile and the hybrid system, that the monopile with diameter 6 meter has larger capacity, but DNV requirement at rotation 0.5 is applied for both of them, so we can use the hybrid foundation system. We provided the equation to be able to scale down the model and to take the effect of the blade. We studied the long-term effect on the stiffness and the rotation. For our future work, at the beginning in the wind tunnel, we assume that foundation is rigid, although it's not actually rigid, so there is some flexibility. So we need to see the effect of this flexibility in our calculated loads. We just study on sand, so we need to see the effect on clay. We need also to have different combination between blade diameter, pile length, pile diameter, and also in the future we will be able to apply the actual time history on our model instead of just applying cyclic load. This is some of the conference and papers from this work. So at the end, as acknowledgement, after thanking for Allah, I want to thank Professor Al-Nagar for his guidance and support during this work and research. Thank you, Professor. For the wind tunnel, I want to thank Professor Germa, Dr. Ali from Louisiana University, Mr. Jerry for their support and the wind tunnel test. Structural lab, I want to thank Dr. Sulaiman, Dr. Attar, Mr. Wolbert, and Mr. Dave from Mechatronic Department. NREL staff, I want to thank Dr. Jason Jankman for his providing us with unpublished data. I want to thank Egyptian government for funding this research. UWO, CE staff, and machine shop. And I also want to thank my friends here for their support during these years. You were like family for me. Thank you guys. At last but not least, I want to thank my dad, my mom, my sister, and all my family back home. I know thanks is not enough, but thank you. Thanks. 40 minutes.
Excellent presentation. This is great. So that leaves a lot of time for questions. So that's your time to get at him.
You should give 10 minutes for acknowledgement.
40 minutes.
Typically, examiners keep their questions to the examination period, but
So, one of the things I'm hoping to understand a little bit more, because I'm fairly ignorant, is how are wind turbine foundations currently designed?
Actually, there is some equation presented by DMV codes. It's a really simple equation to present Vy curve. But as we all know, we cannot just depend on our empirical equation for something with billions of dollars. So we need to have some finite element analysis. Although, as we said, there is some simplification in the analysis. For example, as we said, there was no accurate wind load. So if you just increase the load to be in safe size, so you have larger factor of safety. And as we said, as we have seen here, we can use smaller pile diameter by just adding the plate to be the same or better performer than the 6 meter diameter. So you're already using larger factor of safety.
Okay, so I guess follow-up question is does the current system work?
Yeah, as you can see that the displacement here, as you can see, the lateral and vertical displacement will be less than the 6 meter diameter. The main concept here, as we said in the introduction, is experience in construction. So in North Sea, they are just depending on gravity base because they have experience in gravity base. So if you just have experience in just monopile and don't have experience in this hybrid foundation system, so it will be a little bit hard to have all equipment for this hybrid foundation system. So this will be the major obstacle in this hybrid foundation system.
So if we go with the hybrid foundation systems, how much of a savings is it? Do you know? Do you know the cost between just sticking a pile and like beyond just material costs? Because now it looks like you've got to have 2 crews. You've got to have one crew to stick your 4 meter diameter, and then another crew building your hybrid foundation and then sinking it and attaching it. So I'm really wondering what that cost is.
We didn't calculate actual calculation for the cost, but we already saved in the pile itself 50% from diameter 4 meter to 6 meter. Although we already used concrete, but the concrete will be constructed onshore. Also, the hydraulic hammer to be able to construct 4 meter diameter will be, of course, have less cost than using a hydraulic hammer to install 6 meter diameter. And as we said, the 4 meter diameter is already being used already. So we are using about the same equipment that has been used in 4 meter diameter to be used with hybrid foundation system. And another thing, we can use our hybrid system to upgrade the capacity of the existing foundation system. So if you have 4 meter diameter monopile, you can add just the upper part, which will be connected with concrete plate, to increase the capacity of existing foundation system instead of using or constructing new 6 meter diameter pile.
Okay. So what I get out of that is you're pretty confident that it's going to cost less.
Of course, it needs further calculation,
okay,
but generally,
I have to interject in this one. I've done some study on the cost of installing piles for offshore structures, not the wind turbines. And the cost of installing 6 meter pipe is $17 million. The vast majority of this is not the material.
No,
it is the rental for the barge that will drive it in.
Yeah.
You can use a smaller hammer, smaller barge. The cost goes from $70 million down to $10 million. That's where the savings is.
But the way I see this constructed is that you need 2 barges. You need
The barge to transport it from onshore to offshore, that's very cheap.
Okay.
The expensive one, the barge that has the hydraulic hammer, with enough energy to drive a 6 meter pipe. That's
Yeah.
where most of the
Okay,
money.
that's how I was wondering how this worked. Thank you for the questions.
Enough questions.
What is the typical depth of the wind turbines? Of course, it depends on the type of the soil, but what is the average depth of a pile you can use, for example, here in this area and between here and Windsor?
Between here and Windsor, it will be onshore, but our main concern here was offshore. But for onshore, we have different foundation systems, so it will be cheaper just to use gravity-based foundation system. So just gravity-based, it would be, and sometimes use gravity-based with smaller pile. Sometimes we are using this, but for sure, of course, between here and Windsor, it's just onshore structures.
Then what is the average depth for offshore piles?
It's up to 40 meters, yeah. As we said, for this 5 megawatt wind turbine. But if it's less than 5 megawatt wind turbine, it will be less. Till now, when we started 2011, the only offshore wind turbine with huge size was Hornets Rev, and it was 2.3, and the diameter was 4 meters, and the length was, I think, 30 meters. So it was less than our analysis. That's why we already have used larger pile analysis to make sure that we are on the safe side. Now, the size of wind turbine, it was between 7 and 8 megawatt wind turbine. One of them will be constructed in Denmark. They are under construction for a large wind farm over there.
You said that they increased the pile diameter from 4 meters to 6 meters. Did this increase due to the vertical load mostly or the lateral load?
Lateral load, because of course we have two components, we have vertical and lateral, but the main thing is lateral load.
Well, you've done, you said that the wind farm tests were done at the parking state, right?
Yes.
Or parking conditions. So I'm just wondering, is it more conservative to?
Okay, when we started, we got already published data from NREL for the original situation. But also their published data was not time history, it was just value for different wind speed. So when we started to make our analysis here, we didn't have any situation at parking position. And as we said, the rated wind speed was 11 meters per second for the operational situation, while in parking position it will be 45 meters per second, 47 meters per second. So there is huge difference in load, which should be, I think, triple the load. So we want to know if there is a storm or hurricane, when they have parking position for the wind turbine, what is the amount of load will be on the foundation system. Although in our study, I didn't maybe mention this in the presentation, we have done two analyses. We have done analysis in working position under working load. We have done, but mainly our analysis was in extreme case, which will be in parking position.
Just a point of clarification. The operational loads for serviceability, and these are the published data. What Ahmed produced was for the ultimate limit state.
So they shut down.
And when the wind speed is high, you don't run the turbine, it has to stop.
Yeah.
So it's a park position.
Can we go back to your model and the results in particular, where you were talking about the friction?
That's the American,
Numerical one.
it's just distribution.
Mhm. Clearly, you just got done with your model. So, how far down, like, what's the distance between the bottom of your pile and the bottom of the model?
The bottom one.
This is
It's that distance, right?
This distance in this page, this was 4 meter. This was 4 meter, and I think 60 meter.
60 meters. Okay. Do you think that was enough?
Usually between 3 and 5 meters will be enough. We have done, as I said, sensitivity analysis, so
Okay.
it was good.
And you noticed that as you changed it, it didn't really affect? Okay.
Remember, the main load here is lateral, so
Yeah.
basically it's this condition. It would be more severe here.
Yeah, and I think I could see the bottom of the stress fault, and it doesn't flare out.
Is there a specific design for the connection between the plate and the pipe, or is it is it going to fail, or the failure will happen always in the pile itself?
usually, we have done here a new thing. I'll go back here. I may make longer acknowledgements.
Go home
Okay, yes, guys. So here's the little thing here. So usually in the connection here, DNV code make all the specification for ground connection because he's assuming, as I said, in this system. So he assumed there will be little distance between the two parts. So all his specification for just the ground. But in our case here, we have 1 meter at least diameter thickness here. So the connection here, we didn't focus on it because it would be out of our scope. We were studying the behavior mainly. But stresses here has been studied, although it's not included here in this connection, so it was safe. But the connection itself, according to DNV code, we need to have some shear connectors between this part because it's concrete and steel. So we need to have shear connectors to be able to grout all these parts together by precast concrete.
Test in place, not pre-test.
I can't say that's in place.
There are no more questions. I invite you to the topic.